Hi everyone, welcome to this video. So in this particular session, I want to take you through chemistry. Okay, I want to give you a basic and overview understanding of what the terms that you're seeing here. We just want to have a basic understanding of things like acids, bases, salts, neutralization, alkali. Okay, we also want to learn about concentration, molarity, titration, and things like that. So by the end of this video, you'll be able to understand all these terms. Then I'll also end with a question. I prepared a question where I will talk about acid-base titration problems. These are some questions that will come in your exams. Okay, so you want to stick around until the end of this video. Okay, yeah. So let's just get started. So we want to start with an acid. So you've probably heard this word before. And normally when you hear about this word, acid, what comes to your mind is probably something that burns, something that is corrosive. Of course, you are right. One of the properties of acids are that they are corrosive. They are able to eat up organic material, organic matter. Okay, so let's take it up from there. Let's just take it up from there and learn together. So we shall start with acids. Yeah. So, of course, we've already said acids are what? Are corrosive. By corrosive, I mean they are able to eat up organic material. Okay, they can cause skin burns. They can eat up material like this one. Okay, nylon stuff like that. Okay, yeah. So acids are very corrosive. What else do you want to know about acids? These acids have a sour taste. Okay, they have a what? A sour taste. And these acids usually have a pH value less than 7. Okay, they have a pH value that is less than what? 7. Okay, their pH value is less than 7. Of course, I don't want to go into other properties of acids. Today, I just want to create an overview understanding of what acids are so that people are able to know, because these are terms that we use constantly in chemistry. And if you know these terms, then chemistry will be very easy for you. Okay, yeah. So acids are corrosive. They have a sour taste. They have a pH less than what? 7. But what is an acid? So let's create a definition for an acid. So an acid is a chemical substance that dissolves in water and produces hydrogen ions as the only positively charged ions in solution. Okay? So you know hydrogen ions, they act like a proton. Okay? So every acid that dissolves in water will produce these little ions. Okay? So these little ions will be present. Okay? They'll be present. So there's a substance that dissolved in water. Then after dissolving in water, it produced these hydrogen ions as the only positively charged ions. We call that substance an acid. Okay, so everything that dissolves in water produces these hydrogen ions. Okay, the protons is an acid. That is why there are other definitions that we can use to define an acid, like the Bronsted-Lowry theory, where we define an acid as a proton donor. But I don't want to go into other definitions of an acid. I just want to give you a general definition. So an acid is any substance that dissolves in water, okay, and produces what? Hydrogen ions as the only positively charged ions in solution. That's an acid. Now, what are some of the examples of acids? So examples of acids. Examples of acids are things you've probably heard about, things like sulfuric acid, hydrochloric acid, nitric acid, and things like that. Okay, so what are we saying? Examples of acids. So we're saying an acid is a chemical substance that dissolves in water, produces hydrogen ions. Okay, yeah. What are the examples? Examples are hydrochloric acid. Okay, this is how we write hydrochloric acid. What else? Sulfuric acid. What else? Nitric acid. Okay, and things like that. Okay, so that is what we mean when we say an acid. We also have other acids like ethanoic acid. Okay, so these are acids. So these acids are able to dissolve in water, then they are able to give us that hydrogen ion. I hope you understand what we mean by acids. Okay, yeah, now some acids. So when an acid dissolves in water, okay, it dissolves in water, then it produces hydrogen ions. We say it has ionized, okay, or it dissociates. So for example, hydrochloric acid. Hydrochloric acid will dissolve in water. You can see we have hydrogen ion and the chloride ion. Now, there will be a breakdown of these ions, okay? So this acid will produce hydrogen ions plus chloride ions, right? Like, okay? Of course, it's in aqueous. Okay. So you can see that, oh my, it's supposed to be, okay, yeah. So that is ethanoic acid. Sorry, I made a mistake. There should be a C there. Okay, so your hydrochloric acid, okay, hydrochloric acid dissolves in water, produces hydrogen ions and chloride ions like that, okay? Now, what we say here is that this acid has ionized, okay? It has what? Ionized. It has ionized. It has undergone ionization or dissociation. That is what has happened here. So, all these acids will be able to ionize in what? In solution, in aqueous solution, okay? So, this is a state symbol that means aqueous solution. Yeah, so all these acids are able to ionize in what? In solution. Now, there are some acids that completely ionize and others that partially ionize. Those that completely ionize, we call them strong acids. Then we also have acids now that partially ionize. They partially, we call them weak acids. So the examiner will ask you, what is a strong acid? A strong acid is simply an acid that completely ionizes in aqueous solution. Okay? It's an acid that completely ionizes in aqueous solution. For example, you can see hydrochloric acid. Hydrochloric acid here completely ionizes. Now, what do we mean? What we mean here is if an acid ionizes and there is no any other hydrogen ion left, then that acid has completely ionized. So you can see this acid ionized like that, and all the hydrogen ions that were present in here have been ionized. They have been produced, they have been released like that. So this acid has completely ionized. Now, what do we mean when we say an acid has partially ionized? Let's understand it. Partially ionized, okay? So for example, let me get ethanoic acid. Okay. So this ethanoic acid will partially ionize, and to show a partial ionization, we use double half arrows. So I use something like this. Okay? Yeah. So we use double half arrows. So this ethanoic acid will partially ionize like this. Of course, it has released a proton, hydrogen ion. It's an acid. But you can see that not all hydrogen ions have been released from this compound. So we call this partial ionization, okay? So this is partial ionization. So they'll ask you in an exam, define a weak acid. A weak acid is simply an acid that partially ionizes in aqueous solution. For example, ethanoic acid, okay? Ethanoic acid. That is what I want you to understand. Okay, so I don't want to go into other things that, okay, I don't want to go into other properties of acids, their reaction and things like that. We just want to create understandings of what an acid is, what a weak acid is, and things like that, okay? Yeah. Then remember, I also mentioned something about pH. So the pH of an acid, you can tell whether an acid is weak or strong by the pH, okay? So usually strong acids who have a pH value of 1 to 3, okay? Strong acids who have a pH value of 1 to 3. Anything above that, meaning 3 to somewhere around 6, These are weak acids. Okay, so if you see something like 3.5, 4, 4.5, 5, 6, those are what? Weak acids. And strong acids, for example, hydrochloric acid is a strong acid. Sulfuric acid is a strong acid. You will expect their pH values to be somewhere around 1, 2. Okay? So if they ask you what is the pH of hydrochloric acid, you can just write what? 2, because it's a strong acid. Okay? I hope that is clear. Let's now go to other terms now. We also have okay. We also have things now like bases. Okay, let's understand what bases are. So bases. So bases, we also have alkali. Alkali. You want to understand these terms. These are very important. Okay, so what is a base? So a base is any substance that can react with an acid to produce water and salt. So a base is what? Any substance. So is any substance A that reacts with an acid to produce what? A salt and water. So anything that you can see that behaves in this way is a base. Okay? Normally, bases, examples of bases, most common bases are the oxides and hydroxides of metals are bases. These are examples of what? Bases. The oxides and hydroxides of what? Metals. Okay? For example, someone can say calcium oxide. Okay? Someone can say sodium hydroxide. Someone can say potassium hydroxide. Okay? Someone can say copper 2 oxide. Copper 2 oxide. Okay? So all these are what? Bases. Any substance that can react with an acid to form salt and water is a base. Okay. Now, another term that I want you to be familiar with is something called an alkali. What is an alkali? Actually, an alkali is a base. But what sort of a base? It's a soluble base. It's a soluble base. Okay? The bases that I mentioned here, calcium oxide, sodium hydroxide, potassium hydroxide, copper 2 oxide, some of them are soluble, some of them are solid substances. They can't dissolve in water. Okay? But they are still bases because they can react with an acid to form salt and water. They are still bases. Okay. Now, an alkali is a soluble base. So what's an alkali? It's a soluble base, but I want to have a clear definition. Because it is soluble, this alkali can actually now dissolve in water to produce what we call hydroxide ions. Okay, it can produce hydroxide ions. So an alkali is a substance, or if you want, you can say it is a soluble base that dissolves in water to produce hydroxide ions. So an alkali is a what? A soluble base. And once it dissolves in water, it will produce hydroxide ions. What are these hydroxide ions? What do they look like? This is how we write hydroxide ions, like that. Okay? So these alkalis, they are able to dissolve in water. Then once they dissolve in water, then they will release the hydroxide ions. Okay? Yeah. What are some of examples of the alkalis? So examples of alkalis: sodium hydroxide. What else? Potassium hydroxide. What else? Ammonium hydroxide. Okay. So all these are soluble bases. They are able to do what? To dissolve in water. Then once they dissolve in water, they can release these hydroxide ions. We call them alkalis. Okay. But remember, they are still bases, meaning they are also able to react with acids to form what? Salt and water. Yeah. I hope you understand what we have there. So just like alkalis, I mean, just like acids, alkalis can also be quantified. Okay, they can also be termed as weak alkalis or strong alkalis, depending on how strong they or how they dissociate. So they also ionize. Okay, they also do what? Ionize. So they are able to ionize. So we have strong alkalis and weak alkalis. So if we ask you, what is a strong alkali? A strong alkali is simply an alkali that completely ionizes to form these hydroxide ions. Okay, a good example: sodium hydroxide, potassium hydroxide. Of course, ammonium hydroxide is not a strong alkali; it's a weak alkali. Okay, yeah, meaning it does not completely ionize to form the hydroxide ions. Yeah, so that is what I want you to understand. So I hope you're able to understand, or you're able to know the distinction, the difference between an alkali and a base. So they are both bases. In fact, they say not all bases are alkalis, because some bases are what? Insoluble in water. But all alkalis are bases, because any alkali can react with an acid to form salt and water. Okay, so I hope I've given you the difference between an alkali and a base. Okay, so don't forget that. Okay, so let us look at our another thing that we wanted to look at now from our objectives is this a neutralization reaction. Okay, neutralization reaction. So what is a neutralization reaction? This is very easy because we already know that an acid reacts with a base to form what? Salt and water. This reaction is called a neutralization reaction. Okay, so a neutralization reaction is a reaction between an acid and a base to form salt and water only. Okay, so in a neutralization reaction, we should form salt and water only. If we have other substances that will be formed there, then it's not a neutralization reaction. A neutralization reaction results in the formation of what? Salt and water only. And what species, what substances react? An acid and a base. I hope you understand that. Okay, yeah. So good examples of neutralization reactions: sodium hydroxide is a base plus hydrochloric acid, it's an acid, reacts to form, which we need to form a salt. Okay, I'll give you a definition of a salt in just a moment. But what you're going to form here is sodium chloride. We remove this hydrogen. Okay, okay. When you remove the hydrogen ion and you replace it by a metallic ion or an ammonium ion, what you form now is a salt. So we're going to have sodium chloride plus water. Water is known. Okay, you already know that this is a neutralization reaction. At the end of the day, we should have water. That is why I'm adding water there. Okay. If you want us to add state symbols, this is an aqueous. It's soluble. That is why it's aqueous. Remember, I said soluble bases, the alkalis. That's why I'm putting aqueous. Aqueous, it means something can dissolve in water. This one is also aqueous. This sodium chloride is a salt and it's a soluble salt. So we should put aqueous there. Water is a liquid, like that. Okay, so those are the state symbols. Yeah, so this is a good example of a neutralization what? Reaction. Simply a reaction that involves an acid and a base and results in the formation of salt and water only. Okay. Now, I think I also forgot to mention something about bases. Okay, so the bases, the alkalis actually, the alkalis. So these, so just like acids, we said acids have a sour taste. Okay, yeah, they are very corrosive. They have a pH less than 7. What about bases? Okay, so these ones do not have a sour taste. They actually have a soapy taste, like soap. Okay, so if you've tasted soap before, then you know how a base tastes like. Okay, so they have a soapy taste. Okay, what else? How about their pH? Okay, their pH is more than 7, okay? So they have a pH value that is greater than what? 7, okay? The more the pH value, the stronger the base. The less the pH value, the weaker the base. Just like acids, the less the pH value, you saw that acids with pH value like 1, 2, okay, they are strong acids. Then acids with pH values like 3.5, 4, 5, they're weak acids, okay? Yeah. So, but for bases, for alkalis, the stronger the higher the pH value, the stronger the base. The less the what? The pH value, the weaker the base. Yeah, so that is what you also just want to know. So that is what we mean by neutralization reaction. Okay, so let me now give you a definition of a salt. What is a salt? So a salt is simply a compound formed when the hydrogen ions of an acid are replaced by a metallic ion or ammonium ion. Let me give you an example, then you understand the definition better. Okay, remember in the previous reaction we had sodium hydroxide that reacted with hydrochloric acid to form something, but plus water. We know this is a neutralization reaction, so water should be present, and we know what we should put here is a salt. Now the question is, what is the name of the salt? So we now need to stick to the definition of a salt for us to know what salt we're going to form there. So a salt is simply a compound formed, okay? A compound formed when the hydrogen ions of an acid are replaced by what? The metallic ion or ammonium ion, okay? You understand why I'm indicating ammonium ion there. So once we replace the hydrogen ion, this is what we want to replace. We want to replace it with the metallic ion. Sodium is a metal. So we get sodium and combine it with now the chlorine there. Okay, so it's like sodium and chlorine will combine to form sodium chloride. So what we're going to form here is sodium chloride. That is a salt. Okay, so you can see that a salt is the compound formed when the hydrogen ion of an acid is replaced by the metallic ion. Okay, or the ammonium ion. So why are we saying ammonium ion? Because sometimes I can have this reaction, ammonium hydroxide. Remember I said this is also another alkali, okay? And it's a weak alkali, meaning it does not completely ionize in solution. Yeah, so let's say it reacts with hydrochloric acid. I love hydrochloric acid. Makes things easy. So this time around, we know that this is a base and this is an acid. What's the name of this reaction? It's a neutralization reaction. Okay? Yeah, now what are we going to form? We know that one of the products is what? Water. What else? A salt here. But what is the name of the salt now? We have ammonium hydroxide. So a salt is a compound formed when the hydrogen ions of an acid are replaced by what? The metallic ion or the ammonium ion. This time around we don't have a metal here. No. What we have here is ammonia. Okay? So the ammonium ion will now replace what? The hydrogen ion. So we're going to form ammonium chloride. Like that. So this is a salt. Other salts, maybe I could have copper 2 oxide. Copper 2 oxide reacts with sulfuric acid. Like that. So what are we going to form here? Copper 2 sulfate. So the hydrogen ion is replaced there, okay? Yeah. So we're going to have copper 2 sulfate plus water because this is still a neutralization reaction, okay? Yeah. Other examples, maybe let's have calcium oxide plus nitric acid. What do they form? We know that there should be water. We love water, don't we? Okay, so what else? A salt. What's the name of this salt now? Calcium nitrate. Students will write this. Wrong. That is not how we write calcium nitrate. Okay. Nitrate has a valence of 1. Okay. It's a radical. This is how we write nitrate, like that. It has a valence of 1. Okay. Calcium is in group 2. It has a valence of what? 2. Like that. So this is calcium ion. This is nitrate ion. So if you want, there's a valence of 1 there. So if you swap the species like that, you are going to have calcium. The 2 will go there. 1 will come here, but 1 does not have an effect. So I'm going to have nitrate like that. I put brackets because there's a 2 here. That is how we write calcium nitrate. Please, if you have problems writing the chemical formulas of compounds, then you should just let me know in the comment section. I'll create another video where I will explain about how to write chemical formulas. It will be very helpful. Yeah. So I hope you understand now what we mean by a salt. So that is what we mean by a salt. A salt is simply a compound formed when the hydrogen ions of an acid are replaced by the metallic ion or ammonium ion. Okay. I'll also create another video where I'll explain about where we'll go in details of salts now. Okay. Yeah. So I think we're almost done with our objectives. We now want to look at things like concentration. Concentration. You've heard this word before and you've used it in one way or the other. You'll be like, oh, I think this solution is concentrated. I can't drink it. Okay. This juice is concentrated. Now, what is concentration? We want to understand that. What is concentration? So, before we even understand concentration, we just want to know things like a solvent. We also want to know things like a solute. Okay? A solute, think of the particles that are able to dissolve in another substance called a solvent. So a solvent is a liquid. Okay, a solvent is a what? Is a liquid where the solute dissolves. So for example, if you have water and salt, think of salt as the solute that will dissolve in the water called the solvent. Okay? Now, if we want to quantify, like how many solute particles have dissolved in the water, have dissolved in what volume of the water, then we're talking about what? Concentration. So every time you think of concentration, think of the number of solutes that have dissolved in a particular volume of a solvent. So how many solutes have dissolved in a solvent? That is what we call concentration. So concentration is simply the number of solutes, okay? The amount of what? Solutes dissolved. Dissolved where? In a unit volume. A unit volume of a solution or a solvent or whatever. Yeah. So how many solutes have dissolved in a particular solution? How the number of solutes dissolved in a unit volume of a solution is what you call concentration. Meaning, I can measure concentration. So concentration is just the number of solutes or amount of solutes, okay? Amount of solutes divided by what volume they've dissolved in. Volume of solution. Okay? That is what we mean by what? Concentration. So concentration can be in how many solutes? We can measure the amount of solutes maybe in grams. So concentration can be measured in things like grams per cubic centimeters. It's the number of solutes per unit volume. Anything that is amount per unit concentration. Okay? Yeah. We can also measure concentration in what? Maybe moles per cubic centimeters, moles per liter, and things like that. We can measure it in maybe grams per cubic decimeter, and so on. That is what we mean by what? Concentration. The amount of solutes dissolved in a unit volume of the solution. Now, the other term that is worth talking about The other term that is worth talking about is molarity. These are terms that students confuse, okay? They like confusing these two terms. Molarity. So what is molarity? Molarity is also concentration. Concentration is a general term. When I say the amount of solids dissolved in a unit volume, that's a general term. But when it comes to molarity, we are now being specific. Okay? So molarity is strictly a concentration where the amount should be in moles and the volume should be in cubic decimeters. Okay? So how do we define molarity? Molarity is simply the number of moles of solutes dissolved per cubic decimeter of a solution. Okay? So molarity is strictly the number of moles, okay? The number of moles per cubic decimeter. How many moles have been dissolved in a cubic decimeter of a solution is molarity. You can see that we're still talking about concentration, but in a special way. What special way? Because here we're being more specific. We're talking about how many moles have dissolved in a cubic decimeter of the solution. That is molarity. So what are the units? You see things like, let's say, 2 moles per cubic decimeter. What does this value mean? This value means for every 1 cubic decimeter, there are 2 moles of solutes dissolved in it. Okay? Sometimes you'll see this as 2 molar with a capital letter M. Don't get confused. Once you see this capital letter M, just remember that if this is molarity. Okay? 2 molar meaning molarity. Okay? So this still means 2 moles per cubic decimeter. Like that. Okay? Yeah. That is what I want you to understand. Please appreciate this. You want to appreciate this. That is what we mean, and you should be able to know the difference between molarity and concentration. When I say concentration, I'm talking about just other term. I mean, it's a general term. It's simply the amount of solids dissolved in the unit volume of a solution. But molarity, we're being more specific now. It's simply the number of moles of solutes dissolved in cubic decimeter of a solution. Cubic what? Decimeter. Okay? Or actually, this is also a liter. So you can also say the number of moles of solids dissolved in a liter of a solution. It's also okay. Yeah. So that is what I want you to understand here. So let's now go to our last term that we want to discuss today, which is titration. Okay. Titration. Okay, so titration is a very important technique in science. Okay, this technique is used in medicine, it's used in agriculture, control of environmental conditions, and things like that. Okay, so we use titration. Okay, so before you even understand how it's used in medicine, agriculture, and things like that, we want to understand what titration is all about. What is titration? Okay, what is titration? Okay, so titration is simply a technique, okay? It's a laboratory technique that is used to determine the concentration of an unknown solution by reacting it with another solution whose concentration is already known. Relax. I know it's hard for you to just understand what am I talking about. I'll make it easy for you. So that let's start with an example, then we'll create a definition for ourselves, okay? So let's say I'm reacting to solutions, okay? I have solution A and solution B. So these are reacting. I'm not interested in what they are forming. I'm not interested. I know maybe they'll form C and D. But my goal is not to look at what they are forming, okay? Now, what's so special about these two solutions, solution A and B? So solution A We already know its volume. We know how much volume has been used. We also know its concentration. Okay, now we want to know, probably we know the volume of what? We already know the volume of B. But what is missing is the what? Concentration. This, we don't know the concentration of B. So what we are doing now is we get solution B, we react it with solution A. Why are we reacting A and B? We want to know the concentration of what? B. How are you going to know the concentration of B? Because we already know the volume and the concentration of A. This technique is what we call titration. Okay? So titration is simply a laboratory technique where the concentration of an unknown solution. Let me say that again. So we have solution A and solution B. Solution A, its concentration is known, its volume is known. Solution B, we know the volume, but we don't know the concentration. We are not interested in what is formed. We are interested in determining the concentration of what? B. So we carry out what we call titration. So titration is simply a laboratory technique, okay, used to determine the concentration of a solution, okay, used to determine the concentration of a what? Solution by reacting it with another solution whose concentration is already known. I hope you understand that. You just want to determine the concentration of B by reacting it with another solution A whose concentration has already been given. We call this titration. Okay? Yeah. A good example, what I'm going to carry out is, so usually you're going to have a burette. You have a burette. This is a burette, okay? Yeah, it has graduations there, it's graduated. You're able to read the volume there, okay? Yeah. Then you're going to have a conical flask. You're going to have a flask there. And you can put it on a white towel. Okay. Yeah, so during titration, okay? So during titration, you're going to have two solutions. So I'm going to put, you put a solution there, and you take note of the volume, okay? You take note of the volume. So this volume is known. The volume that, yeah. You record the volume there. I want to explain everything you need to know about titration. I'll also create another video where I'll explain about titration and what you need to do. Yeah. So, but what I just want to share with you is that in titration, we're using a solution whose concentration is already known to determine the concentration of another solution. Okay? We call that titration. So here, I'm going to have another solution. I'll also add some drops, a few drops, maybe three drops of an indicator. An indicator is simply a substance or a chemical that is able to change color when an acid or a base is added to it. So it changes color when an acid or a base is added to it, or it changes color depending on the medium, whether it's in acidic medium, basic medium, or neutral medium. Yeah, so that is an indicator. So we use indicators to help us know when the reaction comes to a stop, because once they change color, we will know that the reaction has ended. They are able to indicate what we call the end point of a reaction. Now, in titration, we have a solution in the burette. We also have another solution in the what? In the conical flask. The idea is, let's suppose I already know the concentration of this one, okay? I know the concentration of this solution. Then I don't know the concentration of B. I already know the concentration of A. So I react A and B, okay? So I'll open the tap there, then I'll carry out the reaction. I'll explain more about what happens there. Yeah. So once the reaction comes to a stop, I'll be able to know what volume had reacted there. Okay. Then if I already know the concentration here, I can now carry out calculations. Okay, I can carry out calculations now and determine the concentration of what this one based on how their mole ratios will be and how the reaction balances. Okay, so I'll be able to determine the concentration of what of B. So it's very important that we determine the concentration of B for maybe various reasons depending on what substance B could be. Okay, yeah. So this is titration. Titration is simply a laboratory technique where used to find or to determine the concentration of one solution by reacting it with another solution whose concentration is already known. Yeah, so titration is very important because it's applied in medicine, okay, agriculture, environmental control or monitor. Okay, yeah, so we use titration to carry out all these things. Okay, we can, it's very important. For example, I would want to know what is the concentration of a particular drug, okay, that is produced. So we want to be very sensitive to the concentration of things like drugs. Okay, yeah, in medicine. Okay, once we produce those drugs, because those drugs will be administered into the body of a person. Yeah, so we want to be very careful and determine the right concentration is given to the patient. Okay, so we can use what? We can use titration to calculate the exact concentration that should be administered into the body of a person. We can also use titration to determine maybe the concentration or any acidity that affected a particular lake or river and things like that. We can also use all these things to determine, yeah, the concentration of species maybe in soils and things like that. I want to know if the soil is acidic, what amount of base should I prepare that will neutralize the acid, so I can now treat acidic soil by knowing the exact amount of the base or acid that if the soil is acidic, I want to know the exact concentration of the base I should prepare so that I completely neutralize the acid. So that is very important. That is what we mean. So that is why we need to understand the basics when it comes to titration. Okay, I think I've explained all our objectives today, but remember, this was just an overview. Okay, I'll create separate videos where I'll go into different topics. Okay, but you now have an idea, and it will be very easy for you to continue studying like that. Yeah. So the next thing, I said I should solve this question, but I think due to time, I'll just create another video where I will solve this question. It's an acid-based titration problem. Okay, yeah. So if you want, you can just take a screenshot, try the problem on your own, then you can post the answers in the comment section. I'll be able to see it. Otherwise, bye-bye and thanks for listening.